Hi guys, so today we're going to be focusing on proving triangle congruency. We're going to focus only on two of the postulates, which is side, 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 and side, angle, side. Because we already did an introduction on these different methods, we're going to get started right away with the examples. Okay. So the first one here, it tells us that the tail of an orca whale can be viewed as two triangles that share a common side. We're going to write a two-column proof to prove that triangle BXA here, this one on the left, is congruent to triangle CXA, right? And then what we know is that AB is congruent to AC, right? So I'm going to mark that AB, that's here, is congruent to AC, mark that here. And we know that BX is congruent to CX. So we're going to mark that here. Okay. Note, I didn't mark these with the same tick marks because these are not congruent. It's this and this and this and this. Okay, so let's get started with our two-column proof. Okay, so I'm going to make one with statement and then one with reason. Right. So I'm going to start off with my given, which is this. So 1. We know that AB is congruent to AC, and we know that segment BX is congruent to segment CX. The reason I can state all this is because it's given. Okay. Unlike when we're doing all of our segment addition, postulate, and stuff like that, here, since I'm proving triangle congruency, I don't have to, again, talk about their measures, because I'm not going to be adding them or multiplying them or subtracting anything like that. Okay, then second, okay, what I can notice based off of this is that as it says, it shares a common side. So here I can prove that this is congruent, okay, and so XA is going to be congruent to itself, okay, and the reason for that is because of the reflexive property. Right? And so this proves my third side. Now I have side, side, side. So I can say that the triangle BXA is congruent to triangle CXA. And the reason is because of the side, side, side congruence postulate. Okay. Please write congruence postulate. Because there's also one for similarity, and we want to note that they're different. Congruency and similarity aren't the same. So please make sure when we're proving triangle congruency and you're using side, 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 or any of the others, you write that it's the side, side, side congruence postulate. Okay. Okay, so why don't you try the next one here, CYP1B. Okay, we're not doing 1A, we're just doing 1B, and then come check your answer. Okay, there's two ways that your proof could have come out, right? So they both start the same with the same first statement and given. So first of all, we know that QR is congruent to RS. Okay, told us it was an isosceles triangle, and so these two sides are congruent here. Okay, and then it also tells us that there's a segment, or in this case I wrote line, RT that bisects angle QRS. And it bisects segment QX, okay? From there, this is where it can diverge, okay? One of them can state that QT is congruent to ST, and the reason is for a definition of bisect, right? It told us that RT bisected QS, which means that it cuts QS into two equal parts, okay? Or, since it told us the angle was bisected, I could also have gone with that. The angle QRT, this angle here, and angle SRT, this angle here, are congruent because of the definition of bisect, that this segment bisects that angle. Okay? Statement 3 would be the same, that they share this side. RT is congruent to RT. That's the reflexive property. Okay? And depending on which statement 2 you want, your statement 4 is that the triangles are congruent. If you talked about definition of bisect in terms of the segment, then that's side, side, side congruence postulate, right? Because it's side, side, and then this side. If you chose to talk about the angle being bisected, then you have side angle side because of this angle, this side. Okay, so because of that extra information that it told us that it bisects both the angle and the segment, there is extra or more information that allows us to use two different ways to prove it. Okay, so then the next one here is we're doing side, 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 but on the coordinate plane, we're going to determine whether these two triangles are congruent, okay? And how we're going to do that is we're going to find the lengths of each of the sides. Okay, so I'm going to find the length of each side here, and then we'll figure it out from here. Okay, so I'm going to start with RT. So RT distance formula, so 2 minus 5 squared plus 5 minus 2 squared. Okay. 2 minus 5 is negative 3. 5 minus 2 is positive 3. Negative 3 squared is 9. 3 squared is also 9, so this becomes square root of 18, which is 3 square root of 2. Okay, so this is just a reminder of the distance formula. Now I'm going to find each one. Okay, so here I found each of the distances because of the order they wrote their congruence statement, right? R, T, Z, and J, K, L. I'm going to maintain that order too. That R goes with J, T goes with K, and Z goes with L. So you can see that in the ways that I wrote the letter and the order I wrote them in. Okay. So when I found each of these distances, so R, T, and J, K, first and second letter here, they were both 3 square root of 2, so that's so far so good. Okay. Then TZ, so second and third letter, KL, second and third letter. Okay. They were both square root of 17, so those are congruent as well. And then the last one I did RZ, that's my third side, first and third letter, first and third, so JL here. And they were both square root of 17 here. And so what that tells me is that because these segments are congruent, okay, RT with JK, TZ with KL, RZ with JL, according to side, 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 they are congruent. So triangle RTZ is congruent to triangle JKL by the side, side, side congruence postulate. Okay, so why don't you try CYP2 on your own, and then once you got it, come check your answer. Okay, as you found the lengths of each side, you would notice that AB and TD are congruent. They both have a length of square root of 5. Okay. BC and DS are congruent. They both have a length of square root of 10. And AC and TS are congruent. They both have a length of square root of 17. And so therefore, triangle ABC is congruent to triangle TDS by side, side, side. Okay. So moving on to example 3 here, we're going to be writing a flow proof, right? So what we're told here is that X is the midpoint of segment BD, and X is also the midpoint of segment AC. Okay, and then we're going to prove that triangle DCA, so it's this one here, is congruent to triangle DCA is congruent to triangle. Oh, sorry, there is a typo. It should be DXC. DXC. So this one here is congruent to triangle BXA, this one here. Okay. So let's start with our flow proof. So first things we know is that X is the midpoint of DB. So point X is the midpoint of BD. Okay. So we're going to put that in like a little bubble. Okay. And we're going to write the reason why, and that's because that was given to us. Okay. Another thing we know is that X is the midpoint of segment AC. Okay. I'm going to put that also in a bubble. Reason I can state that is that was given. Okay. From there, since x is the midpoint of BD, what that means is that dx here is congruent to bx, right? So dx congruent to bx. Okay, so this leads to this. Okay, and the reason why I can say that is the midpoint theorem or definition of midpoint. Okay. From this, x is the midpoint of AC. So x is the midpoint of AC, then I can say that AX is congruent to CX. Okay. And again, that's from this. This is because of the midpoint theorem or definition of midpoint. Okay. So what I've proven so far, dx and bx are congruent. So this is congruent to this. And then from this, I've proved that this is congruent to this. Okay. Then the last thing I notice is for DXC, this triangle here, and BXA, this triangle here, is that they have a vertical angle here. Right? And so that means these are congruent. So I'm going to say that angle DXC is congruent to angle, so it went this way, so that's going to be BXA. And then the reason why I can say that is because the vertical angles are congruent. Vertical angle congruence theorem tells me that. Okay. And then with all of this, this, and this, I can now say that triangle DXC is congruent to triangle BXA. And the reason I can state that is because of the side angle side congruence postulate. Okay, and there you go. Okay, so why don't you try CYP3, and then when you're done, come check your answer. Okay, so this is what you should have gotten. So segment TU is congruent to segment TX. That was given to me, and then I also marked it in my picture. Okay. Angle XTV is congruent to angle UTV. That was also given to me. Okay, I marked it in my picture here. And then the last thing I've noticed here is that they share a side. Right? So TV is congruent to TV because of the reflexive property, and then I just highlighted it there. And then I can now say that triangle XTV is congruent to triangle UTV because of side angle, side congruence postulate. Okay. And there you go. Okay, so now we're going to move on to our next part, which is identifying congruent triangles. We're just going to determine which postulate can be used to prove the triangles are congruent. If it's not possible to prove they're congruent, we're just going to write not possible. Okay. So here we have side here, 2 sides here, and 3 sides here. So this would be side, side, side congruence postulate. Okay. For here, we have angle, 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 angle. There isn't an angle, angle, angle. So that means we can't prove it. None. Not possible. We don't have an no A. We don't have that. Not for congruence. Okay. So why don't you try 4A and 4B, and then come check your answer. Okay. For A, you should have gotten no, not possible. There is no SSA or ASS, so can't prove it because it's ASS or SSA. Okay. For B, you should have gotten side, side, side. Okay. So that's it for today. The next part is on constructing congruent triangles using sides. And so this next part is optional here. Okay. So basically what we're going to do is we're going to be constructing congruent triangles using their sides. Okay. So what I'm going to do first is I'm going to just draw a line here. I'm going to draw a line. I'll use pen. Okay, so I'm going to draw a line. Okay. And then just to help myself out, I'm going to label this A, B, C. Okay. So here in my line, I'm going to pick somewhere just to be my A. Okay. Then I'm going to measure how big AB is. So I'm going to put my pointy part at A, and then my other part at B. Then, after I have it measured with my compass, I'm going to go to where my new A is going to be, and I'm going to draw an arc with that measurement to denote B. Okay, so this is now my new B. Okay, then now all I need is C. So what I'm going to do is I'm going to measure how far A and C is using my compass, right? Because remember, constructions is doing this without a ruler. Okay, so AC, I've got that measured. Then I'm going to move to my new A, and I'm going to make an arc. Okay, so C is somewhere here, but how to know where exactly it is, right? I should now measure where BC is. Right, so BC is here. Then move into my new B, I can make my mark. And that is exactly where C is. If it was somewhere here, it'd be too close to B, but this is exactly the length from C to A and from C to B. Okay. Then all I have to do is connect it. Slightly off. Okay. So here is my replica exactly, well, not exactly because of human error, but almost exactly of my ECB. Okay, so then let's try this again, constructing it using sides. So again, I'm just going to label them so it makes it easier for me, D, E, F. Okay, I'm going to start by drawing a line. Somewhere along the line, I'm going to make D. So I'm just going to put a point anywhere. This is going to be D. Okay. With my compass, pointing end at D, and then measuring where E is. Okay. Then I'm going to move to where my new D is and make a mark across the line, because this is where E is going to be now. Okay. So this is the new E. Okay. And then to find F, now I just need to measure D and F and E and F. Okay, to get the exact length of where F is. So D, so F is somewhere along this arc. Okay. Now I'm measuring E to F. Okay. So E is here, and then I know F is going to be exactly here. Let's move F. Okay, then I just need to connect my dots. So D to, let's use the straight side. So D to F. And E to F. Okay, and there you go. Okay, and so what this is using is the idea of side, side, side. Okay. The other way we can do it is by using side angle side. Okay. So it's going to start the same way first. Right. What we're going to do is I'm going to draw a line. To help myself, I'm going to label it. So this is going to be H-I-J. So somewhere along here, I'm going to just put a dot, and that's going to be H. Okay. Then I'm going to measure H to I, so it starts the same way as the side, side, side method. Okay. So measure to I here. Okay. Then from my new H, I'm going to make a mark. This is I. Okay. Then we're going to use this angle. So I'm going to copy angle H. Okay, I could also copy angle I, but since I already have a marker here, I'm going to try to reduce the amount of markings. So here, in one of our previous videos, we learned how to copy an angle. That's what I'm going to be doing. Okay? So to copy an angle, first thing you're going to do is you're just going to start at your vertex of the angle you're trying to copy, and you're going to make an arc. So I'm just going to make an arc. Okay? And then leaving my compass the same, I'm going to move to my new H and make that exact same arc. Okay. Then what I'm going to do is I'm going to measure how far these intersections are. So from here to here, I'm going to measure it. Okay, so it's about this length. Then I'm going to go to where the intersection is here and make that mark. Okay. So this now measures the angle. And so J is going to be somewhere along here. Okay. Okay. So then I have that measured. Okay. And then now all I have to do is measure either from H to J how far it is or from I to J how far it is. It's up to you. So I'm just going to measure how far I to J is. And then from the new I, I'm going to make my mark, and that's where J is. And then I'm going to connect it. There you go. Here's J. So this is my replica of the triangle. Okay. So let me show you again how this works. This will be K, L, N. Okay, so again, we're doing two sides and the included angle. Okay. So, oh, I should have copied. Sorry, I should have measured this one. Okay. Okay, so then let's draw my line again. Mark somewhere as K. Use my compass to measure KL. So my compass, measure K. Okay. Going to my new K and then marking it. So here's L. Okay. So here's side. Next I'm going to do the angle, and then last is this side. So then to copy an angle again, what I do is go from the vertex of the angle I want to copy and make a mark. Okay. So now moving here, making the mark. Okay. Then going to measure how long the intersections are from each other. Okay. Moving down here, marking that intersection. Okay. So that means M is somewhere along this line because this is how far that angle is. Okay. And then now all I have to do, measure K to M. And make my mark. Okay, so there was my side, the angle that I copied, and my side. And so this here is my triangle. Okay, so that's it. Have a great rest of the day. Bye, guys.